Logarithms and exponentials also have their own derivative and integral rules that we need to know and be comfortable with. The definition of the natural log function itself is actually defined as an integral. ln of x is equal to the integral from 1 to x of 1 over t dt. So there's some advanced mathematics going on here that the natural log is defined in this manner. Now we're going to look at that a little bit further on, but now let's start to kind of look at just the properties. So remember, e and ln have a connection. ln of x and e to the x are inverses of each other. So if you don't know what e to the x is, this is the definition of e. You don't need to know this piece, but it is good to recognize like, oh, e is defined as a limit as n goes to infinity. So even e has this foundational limit process to it. But you do need to know that e is this natural number, which is approximately 2.718. And it does continue, but it does represent a number. Now, e to the x and ln of x, a little bit different because now we're dealing with a function where x is the independent variable, not just a random number. There are some very specific properties of natural logs that you need to know. So as far as the graph of natural log, let's slide over here and just do a little graph. So we're going to put 1 right there. I'm going to go ahead and make that 2, and I'm going to make this e, right? So I'm not going to put a 3 there. I'm actually going to put an e. So anything raised to the 0 power is going to give us 1. Now, just a reminder that this natural log situation does have a base, of e. So we're saying e to some number is yielding x. So e to what value gives me 1? It must be 0. So that's why we always go through that point. And then e to the what power gives me e. So that's going to be 1. So that's why the point E1 exists, and there is a vertical asymptote. So you don't deal with negatives unless the logarithm function has been shifted to the left. So we have the vertical asymptote there. So let's go back to the properties. Your domain is 0 to infinity. Your range is negative infinity to infinity. And some really important features of the function. The function is going to be continuous. We know what that means. The function is also going to be increasing. Basics of logarithm functions. And this is what we call one-to-one. Meaning there's only one y value for every x value and also one x value for every y value, right? So a one-to-one function. Now the graph is concave down. So when we think about that parent function of the logarithm, these are some of the features that we need to be comfortable and familiar with. So let's go ahead and graph a few of these and remind ourselves of just transformations in general. So if I look at ln of x minus 2, I know that this is a shift to the right 2 units. So normally my vertical asymptote appears at x equals 0, but now that vertical asymptote is going to go through x equals 2. Now you still have the same general shape, concave down, continuous, one-to-one, but now I'm going to be going through that point 3 right there. So go through 3, and again, it's going to flatten out, concave down. The value right here at 3, 2 plus e, I keep writing 3. 2 plus e is going to be 1 right there, just to kind of get you that same general shape that we had up here in our parent function. Remember 0, here's the e value, right? That's always going to be 1. So if I do 2 plus e here, I get 2 minus 2, and then you have ln of e, and ln of e is always equal to 1. So just a way for you to think about that. So now let's go ahead and look at the next one. So this is the shift up. So we're going to be going up 1 unit. So we still have the same vertical asymptote, But instead of going through the point 1, 0, we're going to go through the point 1, 1, like so. Vertical asymptote, still here. So a little bit of a shift upwards. So you'll notice I'm not going through the 0.10. The 0.11 is now what exists on this graph as I shift up. Now the 2, this is actually going to be a vertical, let me do that up here. We're going to do a vertical stretch by 2. So all of the y values are going to get multiplied by 2. Now, the y value is 0. 0 times 2 is still 0, right? So even though I'm stretching, I'm still going to go through that point, 1, 0. But now, excuse me, by the time I get to E, I'm going to multiply. The y value was originally 1. Right? But now that y value is 2. So by the time I get here, I get this vertical stretch. But it's still concave down, it's still continuous.